Good day, pupils. If you are watching this video, it signifies that you are physically and hopefully emotionally ready to start Unit 1, Part 3 on systems of equations. Now, this video is just a quick review from Algebra 1 of solving 2x2 systems of equations. Now, a system of equations is just more than one equation in the problem. You're looking for the values that satisfy all of the equations for the values of x and y. So when you took Algebra 1, you actually learned at least 3 methods for solving these. One of them was to just graph the lines and find where the lines touch. We're not really going to mess with that here. We're going to be looking at how do you solve these algebraically. So another method is called the substitution method. That's a method you use when you either have a variable by itself in one of the equations, or if it's really easy to get a variable by itself, you can just take that expression that y is equal to, since I know y is equal to negative 4x minus 12, and I could substitute it in. I could plug it in to the other equation in place of this y. So I would take negative 4x minus 12, substitute it in place of that y. So it would now say negative 3x minus 7 parentheses that negative 4x minus 12, close the parentheses, equals 9. And then it's just a matter of solving that equation. Now I'm seeing parentheses, so there's a D word that should pop into everybody's head when they see that. Distribute. I need to distribute negative 7 to everything in parentheses. So that's going to be negative 3x. Negative 7 times negative 4 is going to be positive 28x. And then negative 7 times negative 12 is going to be positive 84. Equal to 9. Bring that down. Now it's just a matter of solving this equation. Combine these like terms. Negative 3x plus 28x is 25x plus 84 equals 9. Solve for x, so subtract 84. That's going to be negative 75. 25x equals negative 75. Divide by the 25. I've got x equals negative 3. All right, now that is correct, but that's not done. We found the value for x. We still need to find the value for y. So my last step, I can take that part of the answer and plug it into either equation, whichever one looks easier. I'm going to use the top equation. So I'm going to say y equals negative 4. Instead of x, I know x is negative 3 minus 12. And work that out. Negative 4 times negative 3 is positive 12. So y equals 12 minus 12, which is just 0. So that means my final answer here is negative 3, comma 0. So you're just taking what y or x, doesn't have to be y by itself. You're taking that thing that the variable is equal to, substitute it in place of the other equation, work it out, and then once you have one of the answers, plug it back in to either equation, doesn't matter which, to get the second part of the answer. So I want you right now, pause the video, try to work problem number 2 using that same method. All right, hopefully you got it. Let me just show you what it should look like. Number 2, the final answer should be negative 3, comma 2. X is negative 3, y is 2. If you take negative x minus 22, substitute it in place of that y in parentheses, and then you would distribute negative 5 to both of those. Give me 40x plus 110, and then combine like terms, and you can go ahead and subtract that 110 over. 35x equals negative 105, so x equals negative 3. Once you know that, your last step is to just plug that value into either equation. In this case, it's easier to use the second one. So y is going to equal negative 8 times negative 3 minus 22. So 24 minus 22 is going to be positive 2. So negative 3, 2. That's the substitution method. Now, there is another method that sometimes is easier. If you look at problem number 3, right? Yes, you could use substitution to solve this, but you'd have to get either x or y by itself. It'd take a while. It's much easier to use the elimination method. If you notice, everything lines up. The x's, the y's, the equal signs, the numbers. All right, when that happens, look what happens if I just add the equations together. What happens to the x's? They cancel. 5x and negative 5x cancel out, so I could just add the rest of the equations. That's going to be 8y equal to 6 plus negative 14 is going to be, what is that, negative 8. And then that's easy to solve. Just divide by 8. So y is going to equal negative 1. Now, just like all the other problems, once you know one part of the answer, plug it in to find the other part. Doesn't matter which equation I use, I'm going to use the top one. So 5x plus 4, and I know y is -1, equal to 6, and work that out. 4 times -1 is -4. 5x minus 4 equals 6, and solve it. Add the 4, 5x equals 10, divide by 5, I'm getting x equals 2. So my final answer here is going to be 2, -1. X is 2, y is -1. Now, if you look at problem number 4, could I use the same method to solve that? Well, yes and no. Everything does line up, but right now, does anything cancel? No, they don't. I need something to cancel out. So I could still use elimination, but if you look at, let's try to cancel the x's. Right now, nothing cancels. What number would I want to have in front of this x? Instead of a 7, I would want to have what number to cancel out the 14x? I want a -14, all right? So the nice thing about math, about algebra, you could do whatever you want to this part of the problem as long as you do it to the whole problem, all right? So I can change this 7x into a -14 by multiplying by what? By -2. So sometimes when you use an elimination, you have to distribute an extra number first. So I'm going to distribute -2. Again, where did I get that -2 from? This is what I would need to multiply in order to get a -14, in order to be able to cancel these out. So that top equation, I'm multiplying by -2. It's now going to say -14x, and then -2 times -5y is going to be positive 10y equals -2 times 22 is going to be -44. So now I'm lining these two equations up. I'm adding these two together, the new version with that one. So I can cancel out the 14x's. 9y plus 10y going to give me 19y equals -13 and -44. All right, that's going to give me -57. And now just divide by 19. So I have y equals, that's going to be -3. Again, once you know y, how do you find x? You go back and plug it in to either equation. Let's use the top. And you can use the new version. You could use the old version. I'm going to use the original version of that first equation. All right, but it doesn't matter which one you use. 7x minus 5 times -3 equal to 22. So that's going to be 7x. -5 times -3 is positive 15 equals 22. Subtract that 15. 7x equals, that's going to be 7, and then divide by 7, x equals 1. So there's my answer. It's going to be x is 1, y is -3. That's the elimination method. Again, substitution is easier when you already have a variable by itself, or it's easy to get a variable by itself. Elimination is easier when everything lines up and it's easy to cancel something out. Sometimes you have to distribute first to make something cancel. Now the last thing we're going to look at, this word problem. Gabriella's school is selling tickets to a choral performance. How exciting. On the first day of ticket sales, the school sold 14 senior citizen tickets, let's just call that X, and 14 child tickets, let's just call that Y, for a total of $252. The school took in $154 on the second day by selling 9 senior citizen tickets, again that's our X, and 7 child tickets, that's our Y. Find the price of the senior citizen ticket and the price of the child ticket. So first I just need to write 2 equations. All right, so I know first day 14 senior citizen tickets, 14 child tickets, and they made $252. So my equation is going to say this: 14x plus 14y equals 252. Second day, the second equation, they took in 154, so that's going to go after the equal sign. They sold 9 senior citizen tickets, so 9x and 7 child tickets. 9x plus 7y equals 154. Those are my 2 equations. Now, really quick, I want you to pause the video and I want you to try to solve this. Would it be easier to use elimination or substitution? Be easier to use elimination. They all line up. So pause the video now, try to solve it. Okay, did you get it? The answer should have been this. Should be senior citizen tickets cost $14. Children's tickets are each $4. All right, so to do this, if you're going to use elimination, all right, I've got everything lining up. I would want to, it's easier to cancel the y's out first. I want a negative 14 here. To cancel this out, so I would distribute a negative 2. All right, so when I do that, this becomes negative 18x minus 14y equals negative 308. All right, add the equations together. So I have negative 4x equal negative 56. Divide by that negative 4 gives me x equals 14. Remember, x is your senior citizen tickets. So they're $14 a piece. All right, and then go back, plug it in. Doesn't matter which equation you use. It's easier to use the original version of the small one. So I'll just plug in 14 in for x, work that out. We're going to get y equals 4. So final answer, senior citizen tickets, $14. Child tickets, $4. Okay, so now there's a practice worksheet. Has a few word problems and a few just work them out problems. I want you to try those. Bring it with you to class, all right, along with your questions and your wonderful attitude. Y'all have a great day.